Previous episodes of this story arc described some historical revolutions in how people thought about the cosmos. Before the revolution became accepted, there was a time of growing doubt about the established ideas, along with the hardening of the inertia of belief in them. But there came a time when new observations and new ideas made the old assumptions and unquestioned worldviews more of a nuisance than an aid for explanations. The old ideas couldn't explain the new observations without patching them, and the patches became increasingly ad hoc and ill-fitting. The limits of what was thought to be possible needed to be expanded, and that meant replacing the framework of the old way of thinking with a different worldview. It required a change in what was considered to be reality. It required picking up the stick of knowledge by another end. We seem to be in a similar condition today. Modern observations of events in space exceed the possibilities of accepted mechanisms of gravity and gas thinking. But the emerging understanding of electrically active plasma does provide sufficiently expanded possibilities. One of them is the greater power available in plasma systems. In physics, power is the rate of change of energy. With mechanisms that provide greater power, larger events can happen faster. To become familiar with them and to develop them, we need to be playing with larger and faster thinking, or in other words, with power thinking. One distinguishing difference between gravity and gas thinking, typified by the standard model of cosmology, and electricity and plasma thinking, such as the electric universe model, is the matter of power. Plasma systems not only have more energy than gravity systems, they have more power. An excess of energy beyond what would be required for an equilibrium condition flows through them, similar to the flow of electricity in a string of lights, being greater than what's dissipated in an individual light. If conditions suddenly change, for example, a short circuit, much more energy can appear in the system in an unexpectedly short time, for example, an electric arc, such as high-voltage switch arcing. At a stellar scale, the result would be a flare or a nova. I mentioned previously that space-age observations have revealed a universe that is too energetic for its calculated mass. It's also too powerful. For example, the age of the universe, as calculated from a Doppler interpretation of galaxies' redshifts, is too short for the processes of gravity and gas to form its observed structure. Astronomers augmented those processes by imagining dark, unobservable processes that must be there, because otherwise the theories of gravity and gas are falsified. Electricity and plasma processes, on the other hand, can be many orders of magnitude more powerful than those of gravity and gas, and they could aggregate matter over a much larger volume in a much shorter time. Furthermore, those processes are not only observable, but also can be investigated in a laboratory, empirical rather than imaginary. My primary interest in these essays, however, is in the new thinking that these discoveries suggest, the implications of larger and faster for the cognitive framework or assumptions underlying particular explanatory ideas or theories. The present framework was established in the 19th and 20th centuries before plasma was discovered. It assumed that change in the natural world was only by relatively weak mechanical mechanisms that worked gradually and uniformly. The new discoveries expand that framework to include more powerful electrical causes that can be sudden and transient. Astronomical phenomena and plasma behavior have received the most attention, but other sciences and processes are also affected. For example, conventional thinking in geology assumes that weak and slow processes created the formations we see: erosion, sedimentation, an occasional local earthquake or eruption, creeping continental plates. Millions of years are required for significant changes to occur. But an instability in the plasma dynamics of the Earth's sheath, conventionally called a magnetosphere, could trigger an electrical discharge to the surface or below. It might be triggered by an unusually large flare from the sun. Flares of that power have been observed on other sun-like stars. A powerful discharge would scar the surface with craters, canyons, and mountains. A sufficiently powerful one could reshape and relocate continents and oceans in days rather than in millions of years. That would be impossible with gravity. Also, we have experienced the small disturbances in rotation that present-day flares have caused. When the flare strikes, rotation suddenly changes. After it passes, rotation gradually returns to its previous rate as if the rotation were driven, like a motor, rather than being purely inertial. One with an order or two of magnitude greater energy and power could suddenly and significantly change the rotation rate and cause oceans to wash over continents, a global slosh. The resulting super tsunami would stir up the sediment that's distributed around the globe. As the slurry flowed back toward the basins, it would be sorted into strata of like composition and be cemented, perhaps electrically, into distorted layers of rock. Sedimentology experiments have shown that deposition in flowing sediment can lay down multiple strata in non-horizontal and even twisted formations. The sediment is sorted as it's deposited, extending the group of strata downstream diachronically. Time advances not perpendicularly to the strata, one stratum at a time, as assumed by conventional theories, but parallel with the strata, several strata together. A large flare that disrupts the Earth's rotation fast enough could produce the strata we see in the positions we see without needing long times for horizontal deposition and tectonic warping. The effects would be larger than the standard model imagines, global instead of local, and faster, days instead of millions of years. Also, the electromagnetic fields in a large flare could alter atomic decay rates. Decay rates were once thought to be constants of nature, but they have been found to vary in resonance with several astronomical cycles. That means that they're related to their environment. Observations of Torella experiments and lightning strikes have indicated that atoms may be transmuted en masse into other species by the plasma behavior in a discharge. A discharge that affects the entire globe would transmute elements in the debris around the globe. Those materials would then be sorted into like strata in the aftermath of a super tsunami, and radio dating would calculate their age erroneously past the disruptive event. The geological clocks could be reset globally, scrambling the conventional geological record. I've used the term catastrophic to label such a disruptive event, but I have misgivings about that. Larger and faster in geology means sudden global change, but electricity and plasma ideas of sudden global change are distinctly different from past catastrophist ideas, even though much of the evidence, uninterpreted observations, is the same. With new ideas and a new theory, the facts, interpreted evidence, are different. The difference between evidence and facts was described in the first episode of this series, Playing with New Thinking. Perhaps the biggest difference is that many past catastrophist ideas assumed that the gods did it, divine catastrophism. They assumed the intervention of some supernatural mechanism that lies outside the scientific and naturalist criterion that phenomena must be sensible, that is, able to be sensed. They stepped beyond sensation and experimentation into the magic land of must be, and there's nothing more we can do with it. Epistemically and ironically, this is not unlike the role of dark matter and dark energy in astronomy today. It's a ghost in the machine. Another difference is the anthropocentric baggage that catastrophism carries. In the past, before uniformitarianism became the conventional presumption, such change was called catastrophic in relation to human values, scale, and expectations. An event was catastrophic if it greatly disrupted human life. But an electricity and plasma catastrophic event is only a step up in energy and power above non-catastrophic events. A flare that browns out a power grid is disruptive. One that produces a sheath-to-ground discharge leaves a catastrophic crater. It would be better to have a term that only refers to the upper end of an energy or power scale and that does not evoke the anthropocentric connotations. Larger and faster changes the framework with which we understand our experiences of the world. It changes our understanding of how the world works, the stories or theories we compose that make sense of selected ambiguous workings, that make sense to us with our particular and limited nerve arrangements and cognitive faculties. Stories that we tell a lot, especially if they help us invent and run gadgets and processes every day, become familiar. We tend to mistake familiar for ultimate truth. When we encounter an unfamiliar story, we notice the differences from the familiar one and dismiss the unfamiliar one as impossible. It becomes habitual. For instance, conventional astronomers for decades dismissed electrical ideas because, they would say, you can't get charge separation in space. After charge separations were observed toward the end of the last century, they admitted that, sure, there was electricity in space, but it didn't do anything. When the ambiguities of our observations break through the habits of the impossible, we have an opportunity to step into what will seem like a new world with new thinking. An electric universe suggests the possibility that present-day processes could be supplanted by orders of magnitude larger and faster ones. It suggests the possibility that geological formations could be created in a day. It suggests the possibility that the ancient stories of worldwide cataclysms actually happened. The important question is not what happened, but what will we think happened?